All right. Well, thank you for inviting me to be a part of this program, and thanks to everyone who is participating and spending time during lunchtime with us. Today I was invited to talk a little bit about alfalfa winter kill. And I thought a good way to start here is to define what is alfalfa winter kill. What is exactly? There are actually several different things that are referred to as winter kill. We typically use winter kill as a term to determine a bad overwintering of a plant. So we're going to focus on alfalfa today, but it can happen to other crops as well. So there are different ways of winter kill happening. So there's frost heaving, there is tissue damage, and there is also suffocation of the plants. There are also some indirect effects of winter kill. Typically, we can see some increase in disease occurrence in alfalfa stands that have suffered winter kill. And there's also an exhaustion of the resources. So as the plant starts growing and that tissue dies, the plant has to continuously allocate some of the reserves to regrow. So that can exhaust our plants. For each one of these different types of winter kill, we're going to be looking at what it really is, how it occurs, how can we diagnose it. We're also going to look when it is relevant, when and where they're more likely to happen, and also if there is anything that we can reduce the risk for the occurrence of that particular type of winter kill. We're also going to look at some management strategies so that if winter kill happens, how do you evaluate your alfalfa stand and what are some of the alternatives that you can use to manage that? So let's start with frost heaving. So what is frost heaving? Is when there is ice that forms inside the soil. When ice forms, that water goes from liquid to solid, it expands in volume, right? So it ends up raising the soil, and as the soil raises, it brings the plants along. So when that ice thaws, the soil retreats back to where it was, but the plants, the crowns and the roots, they remain in the same position. So they end up being exposed to the elements. These two pictures here are good illustrations of how that looks. So you can see here the crown and the taproot are very exposed to the elements. They can end up desiccating and dying. Here you can see also a lot of the tap roots were really moved out of the soil. One thing that can also happen is breakage of the crowns and the roots. So because that ice and the soil are kind of, they produce a lot of force against the plant that can create openings for disease occurrence. So that's one of the things that can happen as well. So in reality, there are two types of heaving. There is what we call primary heaving and the secondary heaving. And this can be explained with this figure here. So we're looking at this zero here. That's the soil surface. We are looking at the seasons here at the bottom, fall, winter, and spring. And we're looking at the occurrence of the primary heaving in the beginning and end of the season, so in fall and in spring, and the secondary heaving that happens typically when the winter, at like the dead of winter, so when winter weather is very intense. So primary heaving happens when the ice forms right above soil surface. So remember, here's the soil surface. There are needle icicles that form, so they kind of more on a vertical shape, and that pushes the plants out of the soil. They tend to happen more in this kind of short cycles of freezing and thawing. And they tend to be a little bit worse for seedlings, so the plants that don't have a lot of anchorage to the soil. In terms of the secondary heaving, that's when the soil, the ice in the soil forms more horizontally. This happens when there is a deep freeze, so very low temperatures in the soil, and can be detrimental even for stands that are a little bit better established. So knowing that, where does frost heaving typically happen? Very often in poorly drained soils. So if you have water table that is close to soil surface. And we can see that in this experiment right here. So each one of these different columns shows different alfalfa cultivars. And they were planted in soils that had good, mid, and bad drainage. And right here is the intensity of the alfalfa heaving. So the bigger the number, the further away that alfalfa crown ended up from soil surface. So when you have good drainage, so the water table was 20 inches or further down from soil surface, the heaving was a lot lower, so the distance between soil surface and the alfalfa crown was smaller, and it was a lesser percentage of the stand that suffered that heaving, less than 20%. At mid drainage, so that means that the water table was just at around 20% below surface. We can see that the plants were dislocated upwards further away compared to the good drainage soil. And it was also a bigger percentage of the stand that suffered that heaving. For bad drainage soils, the heaving was more intense. Bad drainage, in this case, the water table was just at around 12 inches below soil surface, and all plants suffer from heaving. So again, poorly drained soils are not good for this type of winter kill. It can also happen a lot if the soil temperature is varying. So Jerry just mentioned in the beginning of this presentation that we still have a good coat of snow on soil surface. That means that the soil temperature is quite constant, and that snow really helps with isolating the soil from lower temperatures. So this graph here is showing 3 different years, 84 to all the way to 87. And they're being classified right here with presence of winter heaving or absence of winter heaving. This was for alfalfa. Right here, we're showing the soil temperature. So freezing temperature is right here. You can see that for the winter seasons where there was heaving, the soil temperature varies a lot, going below and then above freezing. And in common, those 2 years had low snow coverage and high precipitation and a lot of variation in temperature. In years that there was little or no winter heaving, there was a lot of good snow coverage, so the temperature in the soil was very stable and low precipitation. So when temperatures are varying a lot, when there's a lot of precipitation and lack of snow cover, we might see more soil frost heaving. So what can we do to manage that, to avoid that to happen? Reducing the fall cutting and or having grasses in mixtures with alfalfa that helps catch snow. There was this study here done in the early 2000s that show we need at least 4 to 6 inches of snow to really adequately protect the soil from variations in temperature. I was very glad when I saw this study because someone else had to stay outside in the winter, keeping those snow covers over the entire winter. I'm sure it was a lot of work. Choice of the field and choice of cultivar are always important. So making sure that you're avoiding soils with poor drainage and that you are looking at the best cultivars for your location. So if you haven't seen the National Alfalfa Forage Alliance has the alfalfa variety ratings where you can look at what are those ratings for commercial alfalfa types. So the next one that we're going to look at is this tissue damage. So that's another type of winter kill. So this happens when there is ice in between the plant cells as the ice forms, the solution in between the cells gets really high in concentration of salts and other substances. So what ends up happening is that water that is inside the cell ends up leaving the cell, and the cell gets dehydrated and can die. There is also formation of ice inside the cell, and you can see here in this figure, this is the plant cell wall, and this is also the plant cell membrane, and they're very close to each other. Here in this dark color, you can see ice formation, and you can see that the cell membrane starts getting a little detached from the cell wall. So this is what happens when the ice forms. It can actually damage the cell membrane, and the cell can collapse and start leaking. So that's how the tissue damage is detrimental for our alfalfa. So when does it happen? It happens typically when we have these varying temperatures, so that we have a green up happening too early in the season. And then that green tissue becomes really sensitive to being damaged by cold temperatures. One way to evaluate is to look at the root rot. So seeing if there is tissue that is kind of brown and soft on the base of the crown. Another way to see it is if there is an uneven growth in your plant and in your field. So if there are areas where the alfalfa is not growing, or if the alfalfa, the plant itself, is going kind of in an angle, that tends to indicate some level of winter kill via tissue damage. If you need to calculate what is your risk for alfalfa winter injury, there's this really cool dynamic tool from the University of Minnesota that you can check out, and the link will be made available on the chat and then later also from the recording. In terms of management strategies, again, choice of cultivar, we want to avoid any type of dormancy breaking too early. So choosing the right fall dormancy and winter kill rating for your location. The other important thing is that cutting schedule really helps with preventing this kind of damage. So this study here is showing the soluble sugar concentration in alfalfa crowns here and the lethal temperature of the crown. So this is when half of the cells in the crown are very damaged. And we can see here that at greater soluble sugar concentration, the alfalfa crown can withstand lower temperatures. How do we make sure that we have enough sugar on the crown and on the taproot? Is making sure that we allow the plants to replenish those reserves. So avoiding either the fall cut or just simply making sure that you give enough time for the plants to recover. Another thing is potassium has been pointed out as an important thing in terms of helping withstand winter kill. And remember, a healthy plant is a plant that is going to survive well over the winter. Moving on to suffocation. Suffocation of the plants happens when we have an ice sheet on soil surface that really prevents that exchange of air between the soil, the plant, and the atmosphere. This can happen when we see a lot of variations in temperature. So when we have a lot of precipitation or snow that melts and then it freezes again, that can happen. And management strategies are somewhat unknown. So you remember here how glad I was someone else did this study looking at snow cover. And so I don't have to do it. Well, things change. So it turns out we came up with an experiment with our collaborators. It's funded and done in collaboration with USDA Dairy Forage. So you can see Matt Siebers here. He's our alfalfa winter kill specialist. This gives me a chance also to thank the Arlington Farm crew. We did this experiment. We started this experiment last year. We're going to do it also in Marshfield. So the crew in Marshfield had something to look forward to. Luana, our alfalfa outreach specialist, helped us with this as well. And my wonderful crew of students And DLF donated the seeds for us to run this experiment. So what we're doing now is we're testing 6 different cultivars with different fall and winter ratings. And we're going to produce this ice or not. So we're comparing it always to a control. So we formed these ice sheets with water and snow. You can see us adding here and how it looked yesterday. So a very nice ice sheet. And we're going to do 2 harvesting schedules moving forward based on growing degree days or in the calendar. So in terms of if Winterkill happens, what to do? There is this really good, very well explained publication by my colleague Landon. So I'm going to go over this a little quickly. But first thing is evaluate your stand. There are some thresholds here, not only in terms of the stems per square foot, but also in terms of plants per square foot. You can also dig out the plants again to take a look at how they are looking in terms of root rot and make a decision whether or not you're going to keep your stand. If you're going to keep your stand, you can simply allow alfalfa to recover. So delay that first cut a little bit more. That's going to decrease the nutritive value, but it will allow you to keep that alfalfa stand. And make sure that you're managing alfalfa for success. So nutrient management is very important. If you are not going to keep that stand, you remember alfalfa is autotoxic, so you cannot replant alfalfa into alfalfa. So that's not an option. So you can overseed it with grasses, or you can terminate your stand and make sure that you're going to take advantage of those nitrogen credits. And sorry about this. These are some of the sources and resources that I used. Again, they're going to be available to you at the end of this presentation. Some of them are also already in the chat. So that's Alfalfa Winterkill for you, and I'll be here for questions at the end.